Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning, everyone. Today I want to talk about wetland restoration and the ecosystem services that restored wetlands provide. Wetlands are transitional zones between terrestrial and aquatic systems, and they perform important biogeochemical functions, such as nutrient cycling and carbon sequestration. When we discuss restoration, we are referring to interventions that return a degraded wetland toward its historical structure and function. Restoration often focuses on three interrelated goals: reestablishing natural hydrology, removing or controlling invasive species, and replanting native vegetation. One of the most widely recognized ecosystem services of wetlands is water purification. Through physical filtration and microbial processes, wetlands remove sediments and excess nutrients from runoff. For example, denitrification is a microbial process that converts nitrate to nitrogen gas and thereby reduces nitrogen loading to downstream estuaries. Another key service is carbon sequestration. Wetland soils accumulate organic matter and can store carbon for decades, making them important in climate mitigation strategies. Wetlands also provide flood attenuation by absorbing peak flows and releasing water slowly, which lowers flood risk to nearby communities. Biodiversity support is a further benefit. Restored wetlands can provide habitat for migratory birds, fish, amphibians, and pollinators that rely on wetland mosaics. To illustrate these ideas, I will use two case studies. The first is the Everglades restoration in southern Florida, and the second is a series of small agricultural wetland restorations in the Chesapeake Bay watershed. The Everglades project is notable because hydrology was dramatically altered by canals and levees. Restoring sheet flow and seasonal inundation was central to recovery efforts. In the Chesapeake watershed, small wetlands were reconnected to streams and planted with native vegetation. Farmers and conservationists worked together to intercept nutrient runoff before it reached the bay. These projects demonstrate that scale matters. Large-scale hydrologic reconnection can restore landscape-level processes, while small restorations can provide important local benefits and serve as stepping stones for wildlife. Restoration success is measured with multiple indicators. Water quality metrics include reductions in nitrate and phosphate concentrations. Biological indicators include return of indicator species and increases in primary productivity. Researchers also measure greenhouse gas fluxes to assess the net climate effect because some wetlands can emit methane even as they sequester carbon. A challenge we face is that restoration rarely produces instantaneous results. Ecosystem responses can lag for years as soils and vegetation recover. Climate change and sea level rise introduce additional uncertainty. For coastal marshes, rising water can alter salinity regimes and drown plant communities if sediment supply is insufficient. Adaptive management is therefore essential. This means setting clear objectives, monitoring key variables, and being prepared to adjust management actions based on empirical results. Economic valuation can help decision-making. By quantifying avoided flood damages or the value of improved fisheries, and recreation managers can compare costs and benefits of restoration projects. Stakeholder engagement is also critical. Local communities, landowners, and government agencies must agree on objectives and share responsibilities for long-term maintenance. If we restore the natural hydrology, the wetland can reestablish seasonal inundation patterns that support native vegetation and denitrification processes. Finally, I want to emphasize that restored wetlands are not pristine copies of historical systems. They often represent novel ecosystems with altered species assemblages, but they can nevertheless deliver many of the services society values. In summary, wetland restoration is a multidisciplinary effort requiring hydrology, engineering, ecology, and social collaboration to maximize ecosystem services and resilience. Over the next class, we will examine monitoring protocols in more detail and compare metrics used in different regions.
Listen again to part of the lecture. Then answer the question.
If we restore the natural hydrology, the wetland can reestablish seasonal inundation patterns that support native vegetation and denitrification processes.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.